All right, hello everybody, and let's get after day 2 of video lecture business. Okay, today we are going to continue on with the advanced kinematic approach. We're just going to look at it solely now in the y-axis. Today we'll call it 1D, one dimension projectile motion, 1D projectile motion. So yesterday we had the kinematic equations. Today we're going to use those kinematic equations in looking at objects as they fly in the air. But with the 1D approach, we're really just going to be looking at objects as they do an up-down situation. And there's some kind of key content things that we need to make sure we have down pat now before we move on to two-dimension motion, which will be after the assessment. Okay. How we kind of have to look at this is through kind of a simulation. So something you've all probably done in your life, hopefully you've done in your life, is simply taking an object and throwing it vertically up in the air and have it coming back down. Okay, and so there's some key physics things that we have to kind of pay attention to and look at that occur during this motion. So, for example, let's say we have a baseball. Boop, 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 boop. Okay, and the baseball gets thrown vertically upward. Okay, so here's like the ground. Okay, and the ball is thrown up. All right. So there's some different things that happen. Hopefully a little bit, this might be a good repeat, but we might have forgotten about it already, which is totally fine. That's what we're going to take a look at, okay? So I'm going to kind of redraw this, give myself a little more space to do some stuff, okay? So we have said baseball, pop, 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 all right? We all know that as we throw the object up, okay, the object goes up, 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 and then begins to come back down, 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 eventually, okay? Well, let's kind of talk about what happens during that motion, okay? Well, the moment that ball is released, we have that thing called gravity affecting the ball, okay? Remember, gravity, lowercase g, is that 9.8 meters per second squared. Okay, but we also have the acceleration due to gravity, a sub g, of negative 9.8 meters per second squared. Okay. So, the moment the ball is thrown up, okay, well, if it's thrown up, there has to be some velocity. So there's some velocity vector v. That'll be in purple. Okay. Well, also, there is some acceleration vector. Put that in green, a, always constantly pushing down against the ball. So as we look at the ball's kind of velocity vectors at various instances, what we should notice is its velocity vector begins to get smaller and smaller and smaller and smaller until it reaches the highest point. Okay? And at the same time, this acceleration vector will constantly be the same amount pushing down at all these instances. So these vectors should all be the same length, but it doesn't always work. Then, once you get to the highest point, okay, the ball eventually comes back down, right? Well, as I kind of talked about yesterday, with velocity acceleration vector, because the velocity vector is going to be pointing down, the ball is going to be beginning to speed up. Okay? So it's going to get faster and faster and faster. While at the same time, this acceleration vector is the same, that negative 9.8 meters per second squared. Okay? So, couple of things to pay attention to. At this highest point, okay, at the highest point right here, okay, something happens, okay? Something has occurred to cause the ball to stop moving, okay? So, at the highest point, I can state that my velocity is equal to 0, this is an always situation. At the highest point, you will always have a velocity equaling to 0. Okay? In fact, it's your velocity in the y-axis. So my v sub y is equal to 0. This is always, always, always 1,000% true whenever a ball is thrown upward some way. Okay? The velocity at the highest point is 0. Also at this highest point, we can call this, so I'll have to kind of draw it down here. Okay, at highest point, the time is called the half flight time. So instead of actually calling it t, usually it's going to be called t subscript 1/2 to let us know, okay, it's the half flight time. So basically, half flight times from the moment it's launched to the highest point. And if you double that, that gives you your total flight time. Okay? All right. Now, we're solely looking at the y-axis right now, so there's no x-axis along with this, so always in the y. So, biggest thing, it's always going to be, that's you really need to pay attention to. Whenever an object is thrown up, okay, up, anyway, right now it's always going to be thrown at like a 90-degree angle straight upward, but eventually we'll be going at different angles. But whenever an object is thrown upwards, at the highest point, the velocity in the y is 0. Okay? So let's take a look at an example, kind of get a little better idea of this. So example, let's say Bubba throws a baseball vertically upward at 10 meters per second. What is the t1/2 delta y max and the velocity at impact? Okay? So a lot going on right here. 3 big questions. So Bubba throws the ball vertically upward at 10 meters per second. What is t1/2, the delta y max, and the velocity at impact? Which, okay, if you think about it, not a lot's given explicitly, but we actually do know quite a bit of information. So starting with my knowns. I'll go in purple for this part. Okay, known. Well, let's see. I know my v initial in the y is 10 meters per second. I know my acceleration due to gravity is negative 9.8 meters per second squared. Even though it's not said, object's in the air. So, yeah, we know that. Okay. Now, what I can also do is say my v final y is 0. Now, what do I mean by that? Well, if I kind of do that same situation, I have the ball, I throw it up, it goes up, and then comes back down. What I could do is I could take this situation and I can kind of cut it in half. I have this first part, which is the going up part, and then the second part, which is the going down part. Okay, so looking at just the first part, okay, the going up part, I can state that my final velocity in the y is 0 because at the highest point, v in the y is 0 at the highest point. So there's my knowns. My unknown is t1/2 delta y max, and then v final at ground. Okay, So those are my unknowns. So let's, I just want to take a look. Okay, let's get after it. Equation. Well, I need to find, let's start with what? I need to find T1 half. Okay, well, looking at my equations, this would be a good time for you to pause, look at them yourself. We end up with V final Y equals V initial Y plus AGT. Why does this one work? Final velocity is 0, initial velocity is 10, acceleration to gravity is negative 9.8, has time, and like I said, this is T1 half. So cancel that out. 0 is equal to 10 minus 9.8 T1 half. Subtract the 10, divide by the negative 9.8, so T1 half is equal to, I don't have a calculator, but I have my cell phone. Hopefully the math doesn't get too weird. 10 divided by 9.8. So T1 half is 1.02 seconds. Okay? So I have a T1 half, so that I can check off. Check. Next, let's go for delta Y max. Well, using T1 half now, that's a known. Okay, I actually don't really need to, but you could. So now it kind of comes to user's choice, because I could use two equations to solve this part out. I could use the delta Y equals V initial YT plus 1 half AYT squared, or I can use the V final squared equals V initial squared plus a 2A delta Y. So let's use that one. Okay, so I have V final squared equals V initial squared plus 2A delta Y. 0 is equal to 10 squared minus, so we'll go plus 2 times negative 9.8 times delta Y max. Now I call it delta Y max because it's the maximum height you reach. If you just call it delta Y, it's totally fine as well. Okay, 0 is equal to 100 minus, okay, 2 times 9.8, negative 19.6 times delta Y gives me negative 19.6 delta Y. Okay, multiply all those things together. Math. Now once again, doing some basic algebra, subtract the 100 over. So 100 divided by 19.6, so that's negative 100 divided by negative 19.16. So negatives cancel out. I get a delta Y max of 5.1 meters. Boom, boom, boom. Okay. Now, last part. What is the velocity at impact? Well, there's one of two ways you can look at this. One of two. You can math this out totally. Could use a kinetic equation. Honestly, you could probably use the third one again. This one, and solve for V final. V initial Y would now be 0. Okay. You could 100% do that. All right. You know what? Screw it. Let's just do it. It's not going to take very long. Okay, it's going to be kind of up in this area. So, like, we're going whoop. So, V final Y squared equals V initial Y squared plus 2A delta Y max. Okay, now we're going. So, now this is the downward part. Let's see. Downward. Okay. So, now, starting like this, I'm now starting up here, and I'm working my way down. Well, if I started up here, velocity initial now is 0. So I have V final Y squared equals 0 plus 2 times negative 19.8 times my height, 5.1. Okay? So let's get the little calcutron. So multiply these things together. So I have, actually this is 5.1. Let's take a look at this. So I'm starting up here, and I'm dropping. So my initial, so we think of this, Y initial is 5.1. Y final is 0. Well, this is change in Y, right? So if we do delta Y, I have 0 minus 5.1, which gives this now negative 5.1. Sorry, this is going to get real messy. Apologize for that. So this is actually negative 5.1, which actually should make some sense because I need to take a negative times a negative because I need a square root, and you can't square root a negative number because that's not right math. So anyway, so 5.1 times 9.8 times 2